And moving on to the next topic, here we are going to understand the chemical characteristics of a solid waste management. See, having the knowledge of classification, it's very important, and we have to know the chemical compounds and the characteristics which is involved in the waste, which is more essential for proper understanding and the behavior of a waste. For example, if a waste which has a rich in radioactive materials, I can't dump that waste in a normal way. It has to be taken, its own precautionary measures has to be taken because it undergoes some chemical reactions in it. And the products which are decomposition by having its own eating value are two examples of the chemical characteristics. If the solid waste are used as a fuel or it is used for any other purpose, we should have their chemical characteristics. For example, the first parameter is lipids. I have a solid waste where this waste it consists of a compound which includes fat, oil, grease and other principal sources of lipids in the garbage, and where the lipids which is having the highest eating value which is about 38,000 kilojoules per kg, which makes a waste with a high lipid content which is suitable for energy recovery. And since lipid becomes a liquid at a temperature slightly above than the ambient temperature, they add to their liquid content during the day waste decomposition. The second parameter is carbohydrates. These are found primarily in the food and in the yard waste, which encompasses sugar and the polymers of sugars. Example like starch, cellulose, glucose, etc. And these carbohydrates are readily biodegradable to produce, such as carbon dioxide, water, and methane. Several gases can be extracted by carbohydrate solid waste. Decomposing the carbohydrates attacks flies and rats. Therefore, it should not be left exposed for a longer duration. So it has to be treated in an earlier way. My third point is proteins. These are the compounds containing carbon, hydrogen, oxygen, and nitrogen, which consist of organic acids and the substituent of amino group also. And they are mainly found in the food and garden waste. Partial decomposition of these compounds can result in the production of amines that have unpleasant odor. My fourth chemical product is my natural fibers. These are rare, generally found in paper products, food and the yard waste, which includes natural compounds, cellulose, like lignin, okay, that resist the biodegradation. Because they are highly combustible in nature, having a high proportion of paper and wood product, they are suitable for incineration process also. The calorific value for this paper products will be varying from 12,000 to 18,000 kilojoules per kg, and the wood which is of 20 kilojoules per kg, and for oil it is 44,200 kilojoules per kg. So it has more treatment where it can be certainly used for many applications. The next one is your synthetic organic materials. I can say in a simple sentence it is a plastic. As we all know that 1 to 10% of plastic have become significant component of the solid waste in the recent years. They are highly resistive and its biodegradation is also very slow. So hence there is a objectionable and the special concern has to be taken care by the solid waste management with respect to this particular waste. Plastic have the high heating value, about 32,000 kilojoules of kg of energy, which makes them very suitable for incineration. But you must note that PVC, that is polyvinyl chloride, when burnt, which produces a dioxin and acid gases, the latter increases the corrosion in combustible combustion system and is responsible even for the acid rain. So the burning technique is not suitable for synthetic organic materials. It has to be treated in a very proper way. The next one is non-combustible materials. This includes glass, ceramic, metal, dust, ashes, which is having an account of 12 to 15% of the dry solid waste only. My next parameter is heating value. An evaluation of potential of a waste material for the use as a fossil fuel for incineration, which requires its own heating value, and it is expressed in kilojoules per kg. So what do you mean by heating value? It's a bomb calorific test where the heat generated at the constant temperature of 25 degrees centigrade from the combustion of a dry sample is measured. CR is one particular table where it gives the inert residues and its heating value for different components. The food waste, which is varying in inert residues, is 2 to 8%, and the eating calorific value is 35,000. Sorry, 3,500 to 7,000. Similarly, when we move towards plastic, cardboards, paper, textile, so it has its own eating value where it has to be treated. Thank you.